examples 6 and 7 from notes 4.1, days 1 and 2 here. First, we're going to define vertical and horizontal asymptotes. So first of all, the line x equal a is a vertical asymptote of the graph of f if, what this notation means, f of x goes to positive infinity. That means the y values shoot up to positive infinity, or f of x goes to negative infinity. That means the y values shoot down as x gets closer and closer to a particular value. And that's what a vertical asymptote looks like. So on our graph, we would have, say this is the value a, this would be our vertical asymptote, and then our graph would be shooting upwards or downwards as x gets closer and closer to that value. A horizontal asymptote, y equals b, of the graph of f is the value that y approaches. So f of x approaches b as x goes to positive infinity, it gets really large, or x goes to negative infinity. The horizontal asymptote, as I mentioned before, describes the end behavior. It's what happens to y as x gets really, really big, either positively or negatively, right? So when we're describing that type of behavior, maybe we have a horizontal asymptote here, and then our graph is approaching that y value as x goes to positive infinity here or negative infinity here. Okay, why do we get asymptotes in rational functions? So this is what I call the big little concept. Here it is. Okay, if c is a number far from 0, that's big, right? Then 1 over c is a number close to 0, right? So if we take 1 and we divide it by a really big number, we get something close to 0. If c is a number close to 0, like 0.01, 0.001, 0.0001, then 1 over c, like think of 1 over 0.0001 or 0.01, that's going to be a really big number. So it's going to be far from 0. So to summarize this, we can say 1 over big, so 1 over a really big number is a little number. So that little number is kind of close to 0, right? And 1 over a little number, so 1 over a little number, something close to 0, is really big. Okay, so how does that apply? So if we take 1 divided by a large number, that happens when we get horizontal asymptotes. Maybe it's going to approach 0. And 1 over a really little number is going to give you something big. That's going to be when we get vertical asymptotes. So using that idea, let's take a look at example 6. So without using a calculator, we want to describe the behavior of the graph as x gets close to 3. Okay, so the first thing we often do with rational functions is you want to factor the numerator and the denominator. In this case, the numerator is already factored, but I can factor out the greatest common factor of the denominator, and I will get 3 times the quantity x minus 3. So when I think about substituting 3 in this function, if I put 3 in, the denominator goes to 0. Okay, so near x equals 3, the denominator gets to be a really small number, right? Because I have 3 times a really small number is going to be small. And then I'll have 3 minus 2, which will be a number close to 1. So near x equals 3, f of x, we have the case where it's 1 over little. And 1 over little is big. Right? So what we're saying then is as x goes to 3, close to 3, y values go to plus or minus infinity, depending on the sign, which side we're approaching x from, as x goes to 3. I'll fix that, as x goes to 3. So we can say that the graph of f of x, which is x minus 2 over 3x minus 9, has a vertical asymptote at x equals 3. Let's flip the page and look at example 7. I'm sorry, I flipped to the wrong page. Example 7 is here. Okay, so without using a calculator, we want to describe what happens to our graph. We have a new function, f of x equals 1 over x squared plus 1, as the absolute value of x gets very large. So that's as x goes to positive infinity, like a billion, a trillion, or x goes to negative infinity, negative a billion, negative a trillion. So if we think about this as x, the absolute value of x goes to infinity, so plus or minus infinity, f of x, we can think of this denominator is going to get really, really big, right? If I have 1 over a billion squared plus 1 is going to be a huge number. 1 over a trillion squared plus 1. So I have 1 over big, and 1 over big is little, which means this value is going to get closer and closer to 0. So when thinking about rational functions, as x gets very large or very small, x, the absolute value of x gets very large, we're describing the end behavior. In this case, f of x equals 1 over x squared plus 1 has a horizontal, has a, let me fix this, a horizontal asymptote at y equals 0. And I want to show you one other thing. I want to show you on the calculator because this will help you with the homework. If you put in a function, so what I did was I put in the function into a graphs page, and then I hit Control T to put a table. And then I want to show you if you do, let me escape this for a second, hit Menu, Table, and then you put Edit Table Settings, put your calculator into ask mode. Usually it's in auto. We'll put the independent value into ask mode. Then you can type in whatever values you want for x. So this is actually the example from number 6, the function from example 6, which was x minus 2 over 3 times x minus 3. And I want to put in various x values near 3 and see what happens. Right? So I want to put in, let's say, 3.01. And when I put that in, you see we get 33.667. Let's go a little closer to 3. 3.001. Now I've got 333.667. And I'm going to put in 3.0001. And then I can see it's shooting up to positive infinity. If I go to 3 from the other side, let's try 2.9. Now I'm on the left side. I'm at negative 3. 2.99, a little closer. I'm at negative 33, 2.999. I'm at negative 333. And I can see when I'm approaching 3 from the left, I'm going to negative infinity. And if I drag back and show you the graph, you can see as we approach 3 from the left, the graph is going to negative infinity, and 3 from the right, the y values are going to positive infinity. This describes a vertical asymptote at x equals 3.